Ambidextrous. Grab a pen and write this phrase with your dominant hand, then switch hands and try again. If the second version doesn't look like it was written like a toddler, you might be closer to true ambidexterity than most people. That's actually pretty rare. Only about 1% of the population is naturally ambidextrous. This superpower might mean that your brain never became quite as committed to one hand as most people's brains do. For many of us, the brain picks a favorite hand early on and keeps giving it extra practice for years. Ambidextrous people still have a dominant side, but the gap between their two hands is often much smaller. It's a bit like having two employees who both know how to do the job instead of relying on one star worker for everything. In the past, many left-handed children were encouraged, or sometimes forced, to use their right hand instead. That means some people who seem ambidextrous today may have learned it through practice, rather than being born that way. Regardless, being comfortable with both hands can make it easier to adapt, whether you're playing sports, learning an instrument, or dealing with an injury. Your brain, in a sense, likes keeping a backup player warmed up on the bench. Mind blindness. Close your eyes and picture a red apple sitting on a table. Some people can practically see the shine, the stem, and the little grocery store sticker. Others get nothing like a picture at all. They know what an apple is, and they can describe it. But inside their mind, the screen stays dark. That experience is often called aphantasia, sometimes nicknamed mind blindness. This quirk reveals something surprising about thinking. Not everyone uses mental pictures to understand the world. People with aphantasia may rely more on words, facts, patterns, or spatial sense. So instead of mentally seeing their kitchen, they might know the layout the way you know a password. It's there, just not glowing on an inner movie screen. The science points to differences in how brain networks connect memory, attention, and visual areas. The visual cortex is the part of the brain that handles seeing, but imagination also needs help from memory and planning systems. When that network works differently, the image may not appear on command. Some people with aphantasia still dream, feel emotions, and think deeply, so this is not a lack of imagination. It's more like having a powerful computer with the monitor turned off, which means if someone says, "Picture this," and your brain says, "I can't see it, but I can describe it," you may finally know why. Tongue tricks. Stick out your tongue and try curling the sides upward into a U shape. If that works, see if you can fold it into a cloverleaf shape with multiple bends. Some people can do it instantly. Others look like their tongues are cramping. For decades, this simple party trick was used in classrooms as proof of a single inherited gene, but reality turned out to be much messier. Your tongue is what's called a muscular hydrostat, which means it can change shape without relying on bones or joints. The same basic design lets elephants control their trunks, and octopuses control their arms. Being able to roll or fold your tongue may reflect a combination of tongue anatomy, muscle coordination, and practice, rather than one magical tongue-rolling gene. In fact, tongue rolling has become one of the most famous examples of science outgrowing an old textbook lesson. Researchers found that the trait doesn't follow the simple genetic pattern many students were taught. That doesn't make the trick any less impressive. It just means your tongue is revealing something more interesting than a classroom myth. It's showing how flexible and adaptable the human body can be. And if you can do the cloverleaf version, congratulations. You've discovered that your tongue apparently has hobbies. Long second toe. Kick off your socks and take a look at your feet. If your second toe sticks out farther than your big toe, you've got what's commonly called Morton's toe. And if you're on a plane, please don't check your toes now. The internet loves to turn this body quirk into a personality test. Depending on where you look, it supposedly means you're a natural leader, descended from ancient Greeks, or destined for greatness. Your toes, however, can't actually make that happen. What this foot shape actually reveals is the architecture of the front of your foot. For those with a slightly shorter first metatarsal, that's the long bone connected to the big toe, there can be more pressure on the ball of the foot and around the second toe. Over time, this increased weight during standing or walking can cause more sore spots and calluses. This might also be why some shoes seem personally offended by your foot shape. So while your longer second toe probably isn't revealing your destiny, it might explain why one pair of shoes feels amazing and another feels like a medieval punishment. Unliftable ring finger. Place your hand flat on a table and try lifting only your ring finger. Suddenly your hand starts going on a strike. If you want to make the challenge even harder, fold your middle finger inward so it's bent underneath your palm while resting your hand on the table. Now lifting your ring finger is like trying to pick up Thor's hammer. What this quirky little test shows is that your hand was built for teamwork more than individual stardom. We tend to think of our fingers as 5 separate tools, but they're more like coworkers sharing the same office. Some have a little more freedom than others, while some are constantly connected behind the scenes. The ring finger happens to be one of the least independent members of the group. Part of the reason is a set of tissue bridges called juncturi tendinum that link finger tendons together. They help your hand create strong, coordinated grips, but they also make certain movements harder to isolate. Your brain adds another layer to the story. When it sends a command to one finger, a little bit of that signal can leak into neighboring fingers too. That's why pianists, guitarists, climbers, and surgeons spend years training finger independence. Even after all that practice, the ring finger still likes checking with the rest of the team before making a move. Supertaster. If you've had black coffee, dark chocolate, or Brussels sprouts and immediately scrunched up your face because of the bitterness, you might be a supertaster. The most accurate test uses special bitter taste strips called PROP or PTC. For some people, these test strips are only mildly unpleasant. For others, they turn into babies who accidentally ate lemons. Taste isn't just about your taste buds. Part of it comes down to your genes, particularly a bitter taste receptor gene, but that's only half the story. The surface of your tongue matters too. Many supertasters have a higher number of fungiform papillae, which are tiny bumps on the tongue that contain taste buds. In other words, some people are working with extra sensory equipment. That heightened sensitivity may have helped our ancestors avoid potentially harmful plants, since bitterness is often associated with defensive chemicals in nature. Today, the effect shows up in much less dramatic ways. Vegetables like broccoli and kale can taste stronger. Coffee, alcohol, spicy foods, and even certain medicines may hit with extra intensity. The upside is that many supertasters can also pick up subtle flavor differences that other people barely notice. So next time when someone accuses you of being a picky eater, tell them about your superpower. Asparagus Pee. Try this experiment at your own risk. Eat a serving of asparagus, wait a few hours, and then pay attention when you use the bathroom. Some people notice a strong sulfur-like smell almost immediately. Others swear nothing happened at all. For years, people assumed one group produced the smell while the other didn't. As it turns out, the story is much stranger. This quirky reaction reveals an important difference between what your body produces and what your brain perceives. When asparagus is digested, it creates sulfur-containing chemicals that can end up in urine. But whether you notice the smell depends on 2 separate factors. Some people produce more of these odor compounds than others. At the same time, some people are simply much better at detecting them. Researchers have even linked part of this difference to genes involved in smell receptors, including one called OR2M7. The important thing is that this quirk doesn't reveal anything about your health, detox abilities, or how clean your body is. So the next time you get embarrassed about triggering a biological chemical weapon at a restaurant, don't fret. Maybe no one else even noticed. Sound rage. You're sitting in a quiet room when someone nearby starts chewing loudly. Everyone else seems completely unbothered. Meanwhile, your brain reacts as if they've just started a one-person drum concert directly inside your skull. If certain sounds like chewing, breathing, tapping, or repetitive clicking trigger an instant wave of anger or tension, you may be experiencing something called misophonia. The problem isn't really your hearing. Research suggests the brain may be assigning far more importance to certain sounds than it should. One area involved is called the anterior insula, which helps decide what deserves your attention. In people with misophonia, specific sounds can get bumped to the front of the line, setting off an unusually strong emotional reaction before there's time to think about it. The sound arrives, your attention locks onto it, and your body gears up to respond almost automatically. Scientists are still debating exactly why misophonia exists, though some propose that maybe those sounds used to signal danger, so tuning into them could help our ancestors survive hidden threats. But in the modern world, when the only felines hiding behind the bushes are your neighbor's cat asking for more food, misophonia can affect concentration and relationships, which is why the person chewing chips next to you may sound less like a snack and more like a personal attack. Post-meal sneezing. Have you ever finished a huge meal, leaned back in your chair, and then suddenly sneezed? Not because of pepper or allergies, just completely random sneeze that seems to arrive with dessert. If that sounds familiar, you may have a quirky reflex known as snatiation. The body's wiring isn't always as neatly organized as we'd like to think. Scientists suspect that in some people, signals telling the brain that the stomach is full accidentally spill over into the circuits involved in sneezing. In other words, your brain receives the message that dinner is over and somehow responds with a sneeze. It's a bit like sending a text to the wrong group chat. Unlike many reflexes, nobody has found a clear survival advantage for this one. It seems to be more of a harmless wiring quirk than a useful feature. The good news is that it's usually nothing to worry about unless it's severe enough to interfere with eating or gets mistaken for allergies. So if you've ever sneezed after Thanksgiving dinner, your body probably wasn't reacting to the turkey. It may have simply gotten a little too enthusiastic about announcing that your belly was full. Lucid dreaming. Think back to the strangest dream you've had. Maybe you were flying over your hometown, showing up to school in pajamas, or somehow having a serious conversation with a talking squirrel. Now imagine realizing, right in the middle of that dream, that you're actually dreaming. If you've ever become aware that you were dreaming while the dream was still happening, you've experienced lucid dreaming. What this reveals is that your sleeping brain may be unusually good at noticing itself. During most dreams, we simply accept whatever bizarre storyline shows up. In lucid dreams, part of the brain's self-awareness system seems to switch back on. Scientists think regions involved in reflection, planning, and self-monitoring become more active, creating a strange hybrid state that's part dreaming and part waking awareness. That ability can sometimes be useful. Some people use lucid dreams to stop recurring nightmares, explore imaginary worlds, or even practice skills in a dream environment. What's especially fascinating is that lucid dreaming appears to be partly trainable. Techniques like dream journals and reality checks can increase the odds for some people. Just don't expect full director-level control over every dream. Many lucid dreamers can recognize their dreaming without being able to rewrite the entire plot, which is probably for the best. Giving your sleeping brain unlimited creative control is how you end up with world takeover plans with a squirrel. Ear wiggles. Stand in front of the mirror and try to wiggle just one ear. If you can do this smoothly, without your eyebrows fighting for their lives, your jaw sliding sideways, or your scalp somehow cramping, congratulations. Your body just unlocked one of the strangest talents hiding in the human body. Surprisingly, this unique gift may mean you have unusually fine control over tiny muscle groups called the auricular muscles that most people never consciously use. Think of it like having access to hidden buttons on your brain's control panel. The muscles that move your ears are still connected to regions of the brain that control movement, but for most people, those controls are buried so deep they might as well be in a forgotten settings menu. The reason these muscles exist at all is even stranger. Many mammals swivel their ears towards sounds like living radar dishes. Humans inherited the hardware, but mostly lost the software. Yet researchers are now studying ear muscle signals to help control computers and assistive technology. So that weird party trick is actually a glimpse of an ancient system that evolution never completely deleted. Which means the next time someone laughs at your ear wiggle, remember, your ears might be running beta software for the future. Hitchhiker's thumb. Give yourself a thumbs up and take a look at the last section of your thumb. If it bends backwards so far that it looks like it's trying to hail a taxi from 1952, you've got what's known as a hitchhiker's thumb. Some people have it on both hands, while others only have it on one. Either way, it's one of those body quirks that tends to surprise people the first time they notice it. Having this bend usually means your joints are a little looser than average. Ligaments are the tough bands that help hold joints together, and in some people, they're naturally more flexible. That extra flexibility allows the thumb joint to travel farther than it does in most hands. Evolutionarily, hitchhiker's thumb doesn't seem to be a selected function, but a tolerated variation within humans. What's more, thumb flexibility actually exists on a spectrum, with people falling at different points along the range. In some cases, a hitchhiker's thumb can also be one clue that a person has flexible joints elsewhere in their body, often called joint hypermobility. And because of this, there could be more discomfort, instability, or strain in load-bearing positions for those of you extra bending folks. If you liked this video and want to learn more about the human body, check out these other videos.